Hey everybody, welcome back from the spring break. In this chapter, we will learn sampling distributions. Sampling distributions is simply the distributions of all the sample statistic. So just in case I did forget about what sample statistic is, let's have a quick review on what is population and what is sample. So imagine you wish to study a very large population, such as if you want to study the average height of all the adult women in the United States, which is called the population parameter. And it's simply not possible for you to survey every adult woman in the United States. So what you're going to do instead is you would look at a smaller sample of adult women from the United States and calculate the sample statistic and use that sample statistic to draw some important conclusions on population parameters. Now the question is, if I take a sample of 100 adult women in the United States from, let's say, Maryland, and then you take a different sample of 100 adult women from Texas, and someone else take a different sample of 100 women from Florida, and then three of us will probably end up getting totally different sample statistic on average height of adult women in the United States. So what shall we do with that? Then the simple answer for that is to get as many samples as possible, right? If you get a big number of samples, and that will give you a better estimate of the population parameters. So now the question is, if I get all the possible samples of 100 adult women from the United States, what the distribution of all the possible sample statistics are going to look like? In other words, how are the sample statistics of all possible samples will be distributed? And that is called sampling distribution. Sampling distributions has two sections. One is sampling distribution of the mean, the other is sampling distribution of the proportion. Sampling distribution of the mean is a distribution of all possible means of all possible samples of a given size. So now let's take a small, tiny toy example, which is population of 4 individuals. Now let's say we have 4 individuals in my population, which is A, B, C, and D. And I know the age for each individual, which is 18 years old, 20 years old, 22 years old, and 24 years old. And I want to get the average height as a population parameter for this population. Although for this case, the population parameter is can be very easily calculated, but imagine the population size is 4 billion instead of 4, then it's going to be a totally different story, right? So let's use this small population as an example to understand what sampling distribution is. So first of all, let's take a look at the population distribution. Because we have 1, 2, 3, 4 different outcomes, then each outcome had the same probability or the same frequency. And that's why the age of my population looks like a uniform distribution. That's simply because all the 4 individuals have a different age, and they all have and each age has the same likelihood to happen. Okay, now let's calculate the population mean and population standard deviation. Population mean is simply the average of all the 4 numbers. So if you take the average of 18 years old, 20 years old, 22, and 24 years old, the average is 21 years old. And if you plug in the numbers to the formula of standard deviation, that gives you the population standard deviation of 2.236. Okay, now let's consider all possible samples of size 2. If I want to know how many possible samples can I get if the sample size is 2, then let's use the different rows to represent the different outcomes of first observation, and let's use different columns to represent different outcomes of second observation. Because I only have sample size of 2, so I only have 2 observations. If my sample size is 3, then I'm going to have 3 observations. So let's say the first observation is 18 years old, and the second observation is also 18 years old. Then the first sample would be 18 and 18. If your first observation is 18 years old and the second observation is 20 years old, then my second sample would be 18 and 20. Now, if I calculate the average, or the mean for each sample, then the mean of 18 and 18 would be 18 years old. And the mean of 18 and 20 would be 19 years old. And because we have 16 possible samples, and that's why we have 16 sample means, and we use X bar to represent sample means. Okay, now since we have the 16 sample means, then we can plot the histogram or the frequency distribution of all the possible sample means. And the 16 sample means give us a distribution which looks like a normal distribution. And now let's calculate the summary measures for the sample means. Okay, so first is calculate the mean of all the sample means, or the average of all the sample means. Because we have 16 samples, so we add up the 16 numbers divided by 16 gives the average of all the 16 sample means, which is 21 years old. And then plugging the numbers to the formula, you get a standard error of sample mean, which is 1.58. Okay, so if we put population distribution and sampling distribution side by side, and let's compare the difference between the two distributions. This is a population distribution. As you can see, there are only 4 outcomes, because there are only 4 individuals, and each individual has a different age. And we have already calculated the population mean, or the average of the 4 ages is 21 years old. And the standard deviation is 2.236. If we take a look at the right-hand side of the sampling distribution, there are 16 outcomes. And this outcome of 21 years old has the highest frequency, or the highest likelihood to happen. And this distribution looks like a normal distribution. The interesting fact is, the mean of all possible sample means is 21 years old, which happens to be the same as the population mean. But the standard error of the sampling distribution is smaller than the population standard deviation. And we'll explain why later. Okay, so now this is this just gives you the idea of what sampling distribution of the mean is in this small, tiny example. And then in the next video, we'll introduce some important concepts of sampling distribution, and we'll show a small example to solve a problem.